Hello, YouTubers. Today I'm going to talk to you about a little optimization technique that I thought about the other day. Let me step back a little bit. I was tasked the other day to optimize a project that was heavily, consuming resources, infrastructure resources, causing a lot of network traffic. It was a legacy project that I needed to modernize. And while looking at the project, I noticed a pattern that I personally used to use in the past that can be improved from being time driven into being event driven. So let's jump in here for a second to the to some to a little architecture high level conceptual model here that I created. So from a high level perspective, let's say you have a service and this service, gets some input and the service stores some data and then you have some time-driven trigger. Let's say every couple of hours it hits the service and sees if some state have changed. And when the state have changed, it does X number of things. Um, this model seems to be a little more wasteful because with these projects, 90% of the time, you'll notice that, the state really doesn't change that often. And if you only do the change when you know the state have changed, it would save you a lot of traffic. It would make your logging on the service a lot easier and a lot less than being pinged through the API every X number of time. So I thought, what if the service could actually tell the time-driven trigger when to trigger the next time? Right? So instead of this model in here, instead it would be a duplex communication where the service could go and communicate both ways. So the service tells the time-driven trigger, hey, the next time you hit me, with an API call, make sure that you hit me at this particular point in time. So instead of pinging the service every 10 seconds or every 10 hours or every 24 hours, it'll tell that time-driven trigger, hey, I just got a new record, and this record needs to be updated at this particular point in time. All right. So what does that look like in the real world? Right? Let's say you have a bunch of products. You say you have an inventory of products, right? Food, let's say milk and chocolate and all that kind of stuff. And you want to make sure that you mark the products that are expired as expired, without having to continuously iterate through the application, right? Obviously, the obvious answer for something like that is for you to say, okay, the next time I view the product, I should show it as expired. But what if, someone is consuming your database or your API and they're just trying to pull the data as is, right? Now you're going to have to put that conditioning everywhere. Instead, what people do today, or the first thing that a software engineer would think about is to write a scheduler. It's an Azure component. It really doesn't matter what the time trigger is, but the scheduler will basically hit the service, let's say once every day. And then when it hits the service will look for products that are expired and then mark them as expired, right? Which means that if you have, let's say 5 products, let's say 1,000 products are the least one of them is going to expire a year from now. That means you're going to have 365 days worth of traffic hitting your product service without you actually getting any benefit out of it, which seems to be a little bit wasteful, right? Because you're hitting a service and you're not getting anything out of it. You're just checking status like a heartbeat or a keep alive, right? That's not the best way to do this. If you were to use a service bus instead of a scheduler, to do something like that, what's basically going to happen, the service bus, the product service would basically put a message every time you add a product through the admin portal. It persists the product in a database, and then you add the product, and then you add a message on the service bus, and this message cannot be visible until the time the product expires. So let's say you're adding in milk and you're saying this milk will expire in 5 days from now, then the service bus will receive a message that says, 5 days from now, make a message visible that the product service would read, and then it will expire that product. So instead of pinging your service once every day to check if the milk have expired, you only ping it one time. You only ping it one time, and this way your logging is much easier to read and a lot less than it would be than having that traffic happening all the time. So I like theories, and theories are great. This looks really great on paper, right? But what does something like that really look like in the real world? So I went ahead and I built you a project, a little project in here that I called it a Vento shop. The event to shop, obviously, because I'm trying to show you a scheduled event or eventual events kind of pattern. What the shop basically does, I'm gonna run the project first just to show you what's going on, um, and then you will see. So I'm just gonna create a product here, and let's say I'm gonna create chocolate product. And the product condition is good, but this product expires on September 15th, 2019 at, I'm going to put it 1 minute ahead of where it is right now. So it's 8 a.m., 06 a.m., right? I'm just going to create that guy. So as soon as I create it as 06, actually, that's a bad example. Let me clean up my, I meant 06 and it wasn't, let's try this again. Let's say milk. And then I'm just gonna pick up the date and time right now, and then I'm gonna say at 8 o'clock 07, it's 06 right now, AM, this product will expire. So this product basically expires within 1 minute. So now it's 07, the product immediately expired. What happened is that I basically put a message on the queue, and I said, um, when it's the right time for this product to expire, make that message visible and then expire that product without me having to do anything. I'm gonna put something in here for like 5 minutes. Let's say beef, whatever. And here we go. And I'm gonna put it's 8 o'clock, and then let's say 8:10 a.m. Right? So it doesn't matter, like you're creating this product, it doesn't matter really whether you're alive on the service or not. You have this background worker, but this background worker is much more intelligent than keep hitting the service and trying to check for the status of your products or doing a proc or all that. It just doesn't seem to be the right way to approach a problem like that. Now, given, I'm not saying all time driven operations are bad. Like for instance, in accounting, there are operations that run on monthly basis. So whether you have event or not, you should run at the end of the month and calculate the revenue or whatever people are doing at this. So there are cases where this makes sense, but there are cases where this doesn't. Even from an engineering standpoint, if you know when something needs to be checked out, why don't you use event driven, scheduled event driven, or eventual events where you get to um, only trigger the event when the time is right. When the time is right. I want to show you how this code works on the back end because that's really the interesting part of it. It's not 8:10 yet, so this guy would continue to show as good. And I'm going to keep the project running, but let me show you from a high level perspective here, what are we doing? The people who are familiar with the style how I architect my projects. This is a fully test-driven project that I'm going to share with you. But we have brokers, we have services, we have controllers, and we have a bunch of models, right? So let's start from the model. We have a product, and this product has an ID and a name and a condition. The condition can be either good or expired. And I couldn't find a good opposite term for expired, so I just used good. And then there is expiration date, right? So you're setting the expiration date on the product, and you're saying this product will expire at this particular point in time. Um, I also have here the product expiration event, which is the event that I save. It only saves the product ID and the expiration date of the product, right? So you don't really have to save the entire product, all the details of the product, serialize that entire product in the service bus. You're just saving the stuff that matters, the stuff that you're going to use. So if you go to the events broker in here, we're using something called the IQ client, which comes in from Microsoft Azure Service Bus. And what this guy is doing, it's basically using that queue client to send a message. So this is when we try to persist a message. And then the other one, let me um, zoom in the picture, the code here for a little bit. Um, and then there is listen to events. And the one that listens to event basically registers a function that gets passed into it. So the input parameter here is basically a function that gets passed in from the outside, from the service layer to the broker layer, right? Testing that is very easy, by the way. It's not that complicated. And then there's the exception received handler. I don't really do anything with this. This is just there for for convenience if people want to do something with this. But in reality, you could use logging, you could do whatever you wanted here, but I'm not really doing anything with it. I'm extracting the context and then I'm saying task, completed task. There's nothing in there. All right, so we have all that going, and then we have a storage broker. It's basically just the CRUD operations of adding, removing, and getting a product by ID, just typical data operations, and these are the implementation using the entity framework. There's no magic there. Um, if you look at the product event service, this is where the interesting code happens. We're using the events broker and the storage broker. I'm going to tell you now why. Um, the events broker, there's listen to products event. So on runtime, we're initializing that listener, right? We don't have to have a special event executing that listener. And there's probably better ways to kick off a background worker jobs on an ASP.NET application, but this seems to be convenient enough for the purpose of this demo. We have create product async, which what happens basically is that anything that consumes this service doesn't know about the built-in models that come in with service bus. And I talked about that when I talked about ASP.NET fundamentals. You know, you're not supposed to, you need to have some sort of mapper between the outside world, the core of your business logic, and the outside world. Do not use your libraries, your external libraries models in your application, in your business logic. That makes a hard coupling, hard dependency that makes it a lot harder to work with if you try to upgrade or update your libraries in the future. So I'm passing in a product and I'm creating from that product something called product expiration event, right? So create product as message, right? I'm creating a product expiration event. I'm serializing that as a string and then I'm sending it as a byte. And it's a byte because see, that model dictates that you need a binary to be sent in. So I'm basically turning it into a JSON and then converting that back into a byte. But the tricky part here is to set the scheduled in queue time UTC to the expiration date of the product. So the message will not be visible on that queue until the time the product expires. And I know someone might be asking right now, what if I go and change the expiration date of the product? Now my product is in jeopardy. Now the product is going to expire when it's not. What if someone made a data entry error and entered it at September 1st instead of October 1st, right? And now the product will expire before it actually expires because they went back and updated the message. I'm going to show you now how we handle this very shortly. So all right, so you have create a product as a message. People, the when the product service creates a new product, gets called with a new product. It takes in this product, converts it into a message, and then calls the events broker and send message async, which creates a message on the queue, right? Um, the other method that I have here is listen to products events, which basically is calling the events broker and sending in this method here, expire product async. Let's take a look at this guy. This is the reader. So when this reader method, basically when you're getting a product, when you're getting a message, when a message becomes visible, we go ahead and do the reversal of the serialization that we did. So we deserialize, we bring it back from a binary to a string, and then we deserialize it into a product expiration. But we check for a couple of things in here. The first thing that I check for is whether I go look up for the product by ID. The product ID will never change because that's not in the user's control to change the ID of the product. So this is going to be always consistent. I go and see if the product exists, and if the product doesn't exist, right, I won't move on. But if it does exist, if it's not null, I go make sure that the expiration dates match. So even if the product exists and the message is in there, I want to make sure that the expiration dates match. If the expiration dates don't match, then I'm not interested into moving forward with that. So once the expiration, I verified the expiration dates match, then I just go and update the condition of the product to expired, and then I update the product calling the storage broker, right? If you look at the product service layer, everything is basically CRUD operations, except for the add, it has something additional to it, which is create product event async. Create product event async, which is basically the idea of it here is to do is when you create a new product, it'll put a message on the queue. Let me show you that in action. If you go to Azure, you're basically, oops, my session expired. Let me go back to Azure again. If you go to Azure, I created a service bus, and basically the service bus has a bunch of queues. And these queues, I called it product. So if you look right now, let me zoom in. So active messages count is 0, right? There is no messages on the queue. But if I go to my product, first of all, before I do that, remember how we said this guy expires at 8:10. It's 8:17 now. So if I refresh that guy should be expired. So you see, it's really event driven. There is no pinging happening in there. So anyway, let's go and create another product in here. Let's say, I don't know, tomatoes. And I'm gonna set tomatoes for another 10 minutes from now. So it's, or maybe 3 minutes, 8, 17. So 17, let's make it 20 a.m. and create. Once I create that, what's gonna happen is, if I refresh this page here, it's going to show you that there is one new message scheduled message count on the queue, right? And this scheduled message count will not be visible for my ASP.NET service to consume until it's ready, right? Now, this is a very simple way to handle scheduled events rather than hammering your API with calls all the time. That's just nonsense. You shouldn't do that if you know for a fact when an item needs to be checked on. You could even take that model to the next level, and instead of saving the product ID, you could save just the date and say, every time there is a product with that, you could even optimize that by saying it's like a handover. You could just go in and say, if the product expires at the 1st of October, and you know there are other products that also expire at the 1st October, then do not create a message. Then do not create a, you don't need to create a message, right? And then you don't create any messages for any products or after than that. But when you already update the existing products, then you create a new message for the next soonest next expiration date, right? So that means at any point in time you will only have a handful of messages in your queue rather than creating a message for each product you add on your database. There's very, very smart ways you can go about, controlling the size of messaging in your queue. It's up to you. It's really easy to follow if you're working with Azure Service Bus or any other queue count. You could do the exact same. Originally, I wanted to do the exact same thing with Azure schedules, but Azure schedules, consuming them and controlling um, the timing on these is really cumbersome. It's not that straightforward. You have to create webhooks and then, fix these webhooks to create a new job. It doesn't seem to be like the right way to go about doing that. Azure Service Bus is a lot easier. There's also Event Bus, I think. You could use that solution as well. That's fine. Um, Anyway, let's go back to the setup of this thing. So in the startup here, you'll notice that I added in service bus configuration. So all you have to do is to get the connection string and the queue name and then initialize your queue client with that stuff. The queue client is the library that comes in out of the box. So where did I get that stuff from? Because I kept looking for that stuff for a while. It wasn't pretty straightforward to find. So if you look at, so this is the queue. If you look at, this is event source. So there's a service bus. It's called PITS products, right? And if you go to shared access points and then click on that, uh, it will show you the primary key, the connection string, and all that kind of good stuff. So that's basically where you copy that stuff and put it in your configuration. What I'm going to commit in my configuration for you to take a look at is basically the connection string. So you can, initialize and create your database, but you're going to have to create your own service bus to get that stuff working. All right, so that's pretty much it. It's a very simple solution. It's already 8:21, so if I go back and refresh my solution here, this guy will be expired. So this is fantastic. This is it'll save you a lot of work. You don't have to do a lot of pinging to your service. It's much more optimum than using a scheduled job. So that's pretty much it. If you have any questions, I don't know if this pattern already exists or not, and I like to call it eventual eventing or scheduled eventing, where you are firing an event, like when the user adds a new product on the system. They have already created an event, but that event doesn't execute right away. We are scheduling it, holding it back until a particular point in time, and then we're firing that event. If you have any questions, comments, or concerns, feel free to reach out. I will try to answer your questions as soon as I can. And if you find this video useful, please share it. Don't forget to like and subscribe. And I'll see you in another video. Thank you for watching.